Good evening everyone. I will present and explain a simple C++ program that calculates the total cost of food items and computes the change from a given payment. I will break down every line, discuss the program's purpose, explain key points, and show the final result. Line-by-line code explanation. #include IOStream. This is a header file. It enables the program to use input and output functions, which are necessary to display text and results on the screen. Without this line, the program cannot show any output. Using namespace std. This line simplifies coding. It tells the program to use the standing library, so we don't have to write extra terms like std before commands such as cout. It makes the code shorter and easier to read. int main. This is the main function, the starting point of every C++ program. All the code written inside the curly braces, open parentheses, close parentheses. Here will run when the program is executed. int burger equals 45, int juice equals 25, int chips equals 35, int payment equals 150. int means these variables store whole numbers, no decimal points. We assign values. The price of a burger is 45, juice is 25, and chips are 30. And the amount paid by the customer is 150. These store the data we need to calculate int total equals burger plus juice plus chips. Uses the addition operator plus to add all the item prices together. Calculation 45 plus 25 plus 30 equals 100. The result is stored in a variable total. int change equals payment minus total. Uses the subtraction operator to find the remaining money after payment. Calculation 150 minus 100 equals 50. The result is stored in a variable change. cout, total cost, total, and dl. cout remaining change, and l. cout is the command used to print or display text and numbers on the screen, connects the text and values we want to show, and L ends the current line and moves the output to the next line. Return O. This line signals that the program run successfully, ends the main function, and returns control to the system. Purpose of the program. This program simulates a basic transaction process like buying food in a canteen or store. Its main purpose is to automatically calculate the total amount to pay and determine the change from the money given, instead of doing math manually. The program computes everything instantly and accurately. It demonstrates how coding can be used to solve everyday problems and make tasks faster and easier. For this, importance of operators, float values, and if-else statements. Operators are symbols that perform actions or calculations. In this program, adds values and subtracts them. They are essential because they process in data and produce results. Without them, the program cannot compute totals or change. They are basic tools that make calculations possible in code. Float values. We use int here because the prices are whole numbers. However, if prices had decimals like 45.50 or 25.75, we would use float. Float is a data type that stores numbers with decimal points. It is very important in real-life applications like money, measurements, or scientific data, where accuracy and decimal values are required. Without it, we would lose precision and get incorrect results. If-else statements, although not used in this example. If-else statements are crucial because they let the program make decisions. For example, we could add if payment equals total, compute change, else show insufficient payment. This makes the program smart and interactive. It can react differently based on the situation. Without if-else, programs only run in one fixed way and cannot handle different conditions or errors. When you run the program, the screen will show in plain text. Total cost 100, remaining change 50. This means the total cost of items is 100 and from a payment of 150, the change is 50. Now let's move to Module 2. Here we expand our previous program to include a service charge, and I will explain each line, talk about its purpose, highlight the use of float, values, and operators, and show the updated result. Float is a data type used to store numbers with decimal points. Unlike int, which only holds whole numbers, it is essential here because the result will have decimals. Service charge. This variable stores the calculated fee added to the bill. Total 0.055. Uses the multiplication operator. It calculates 5.5% of the original total cost. Example, if total is 100, to 100 times 0.055 equals 5.50. Service charge is 5.50. Float final amount equals total plus service charge. Final amount stores the complete amount the customer needs to pay. Total plus service charge uses the addition operator plus it adds the original price and the service fee together. Example, 100 plus 5.50 equals 105.50. Final amount equals 105.50. See out service charge, and out. Displays the calculated service charge on the screen including decimal values. See out final amount to pay, and L. Show the total amount after adding the service fee. This is the actual amount to be paid. Return 0. Ends the program successfully. This program improved the first one by adding a service charge calculation, which is a common in restaurants, hotel, or service-based businesses. Its purpose is to compute the extra fee and show the final exact amount due. It demonstrates how to handle percentage and decimal values, making the calculation more realistic and great for real-world use. Multiplication. Essential for calculating percentage, taxes, fees, or rates. Without it, we cannot get proportional amounts. Addition combines the base price and extra charge to get the final bill. Operators are the core tools that transform basic numbers into meaningful results. Float values. We use float here because the result involves decimals like 5.50 or 105.50. If we use int, it would remove the decimal part and give wrong values. Example, 5 instead of 5.50. Float is critical in finance, pricing, and measurements. Where precision matters, it ensures we don't lose cents or partial values in calculations. If-else statements, even though not written here, they remain very useful. For example, if total 500, service charge total 0.05, L service charge total 0.10. This lets the program apply different rules automatically, like lower fees for bigger orders. It adds logic and decision making the program adaptable to different scenarios. Based on our earlier example where total equals 100, plain text service charge 5.5, final amount to pay 105.5. This means the service fee is 5.5 and the total amount to pay is 105.5. This includes the explanation for Module 2. We saw how to add fees, work with decimal, and make calculations more accurate. This is program 3. It checks if the money paid is enough to cover the bill. Let me explain it clearly. Hashtag include iStream using namespace std int main. Standard setup. Let the program show output and marks where it starts. Float payment 150 pesos. Float final bill 105.50 pesos. Float stores number with decimals, ideal for money values. Hold the amount given by the customer and the total bill amount. If payment equals final bill, see out payment accepted, and L. If checks is payment greater than or equal to the bill. Comparison operator that compares two values. If true, shows payment accepted. Else, open parentheses, see out insufficiently payment and L close parentheses. Else runs only when the if condition is false. If payment is too low, shows insufficiently payment, return 0. Ends the program successfully. It verifies if payment is enough. It adds decision making so the program can judge and respond differently based on the situation. Operators compare values to make decisions. Float keeps exact decimal values important to accurate money calculations. If else, lets the program choose result. This makes it smart and interactive. Output, payment accepted because 150 is more than 105.50 pesos. That's program 3. We now have a complete system, calculate costs and add fees and check payment. Thank you.